Okay, thank you for having me. This is my first time in Belarus. Very exciting. Ex-Soviet country. KGB all around. So the reason I'm putting this is because I want to make sure I have the right timer, okay? Because there's a lot to cover. So I ask you if you have questions. If it's an urgent question, shout it out, and then I'll try to answer. Otherwise, let's wait for the end, just because I know there's a lot of material. But what I hope to do is to give you guys an introduction to Bosch, but an introduction like you've not seen before. It's going to be difficult, but it's going to get you to everything, okay? So let's get started. So I'm Max. Okay, so first problem is, what are we trying to solve? What I want to show you is that the problem we're solving with Bosch is a problem we've always had in computer science. I'm sure a lot of you are computer scientists, and you're going to see, and I'm going to prove to you, it's the same problem we've had for 60 years. Okay? What is it? It's a problem of packaging and essentially distributing software. Okay? Why do I say it's a problem that's been there forever? Let's take a look back. Let's go back in time, right? So what is this? This is a picture of the time of Alan Turing, where people use computers. The way you program it is you use tubes, basically. You plugged in stuff, right? And then the whole software was essentially loaded mechanically. And then what you had is you had a computer and the software packaged and then distributed. That was the 1960s, right? 1950s, 1940s. Around the world, War II, that destroyed the city, obviously. So sad result, but that's what it was. And you distributed your app as part of the whole software. What happened in the 1960s? This is a picture of the IBM 360, actually in Germany, right? What did we do at that time? A little bit different, obviously. So we had mainframes, right? IBM invented that. We had sort of a paper revolution because you had like punch cards. That's where you essentially, some people nodding their head, maybe they remember. That's how you program, right? And then how did you package it? You package it as a book, essentially. You shipped it, maybe FedEx, UPS, or something like this. That was your software, right? And after that, we went to essentially floppy disks in the 1970s, right? And some people, most people here should at least remember, maybe not the people in the back, but you probably remember these. These I remember very well. I mean, I used to have a stack of these things. You know, Microsoft would send you a stack of them, right? And that's essentially how you program, you put the bits in here, and then you distribute it that way, right? So basically, the evolution here is that you would use essentially a piece of plastic, and then you would record the bits in there, and then you distribute it to different people. Then we evolved to essentially a mini computer or computer that most of us have here, except, you know, they're a little tinier. And at the time, you essentially have hard drives. So you don't necessarily you still package in some ways in bits, but you keep it in a hard drive. So you don't have to like switch the disks. You have essentially all the bits in one place, right? Little hard drive, maybe 80 gig. Now the USB key that we have is like almost a terabyte. So that's kind of where we were. Then we sort of went in the 1990s where we evolved towards GUIs, right? Microsoft Windows 95 and Apple, of course, where we would start programming in an IDE. We still have to package things in some kind of a hard drive, right? You have to compile and so on. And then you distribute to something a little bit better, like a DVD, where all of your software is like a copy hard disk of the bits, right? That's the distribution model. Then after that, we went to the 2000, where essentially the web connects us, right? Like I can send an email from here to, you know, the US, no problem. And we're still using IDEs, but we essentially are using the programs or web pages, so you can execute anywhere, right? But you still have to ship it to some kind of a server. And that's kind of the problem here, is that you have the way you build the software, the way you package it, and the way you distribute it is changing, right? But it's still the same problem. And then, of course, these days, it's the cloud, where what you want is you still writing and compiling on IDEs, and you got to package it somewhere and push it. So, for instance, CF push is a good example of that. So you have your bits, you push it to the cloud, right? And it executes in a cloud. But you still have to package them. So how do you build the software itself that's going to run all of this, right? That's the problem. So in a nutshell, what I'm showing you is that even though we've gone through 60 years, there's still a problem of writing code, packaging it, distributing it. Those three pieces are still very much important. They've always existed with us, and they just changed, but it's still the same problem. So how do you write it, compile, package, distribute in the cloud? And what you want is you want it to be reliable, repeatable, right? And cloud agnostic in the sense that you don't want to be one specific version for IBM Cloud, one specific version for Google's Cloud, one specific version for Microsoft Cloud, right? Or Amazon's Cloud. You would like it to be agnostic. That's essentially what Bosch does. It's that problem. It solves that problem that's been around for 60 years or more. So when you learn Bosch, you learn a way to solve this problem in a modern way. It's not the best. I think it's the best. Some people don't. But it works. And in some ways, it does all of those pieces. I don't think there's any piece of software right now that does all of those. And you can challenge me later, and I'll try to answer. So what we're going to do for the rest of this talk is to jump into Bosch and see what it is, the main features. Then we'll talk about the current new features, and then we'll talk a little bit about the future. Obviously, we don't have a lot of time, so I'll have to kind of, rush to some parts of it. And it does it in a consistent, repeatable, scalable manner. And that's important because in the cloud age, that's exactly what you want. You want to be able to, at any point in time, repeat your environment in another place. So we use it, for instance, for Bluemix, which is our Cloud Foundry installation. All right, so what are Bosch? What is Bosch? The architecture is actually pretty simple. You have something called a release, which is essentially software that you package. You create a manifest that tells it, hey, I want to take the release, usually a bunch of release, so not just one, and I want to push it to a cloud. Oh, and then when I do that to the cloud, I want to have some hard disks, and I want to have some number of VMs, and I want to have this network between them. So in the manifest, you describe all of that information. The cloud config is essentially where you say, hey, for this particular cloud. So instead of the Microsoft cloud, I want the IBM cloud, and I want those details. There is something called a director, which is essentially a manager of all of these releases and all of the VMs and so on. So you talk to that director. You have to deploy that director itself using Bosch, but forget that for a second. You just think you're talking to a director. Think of it like a traffic controller, like a cop, central brain. There is something called a stem cell. The reason you need this is because in the cloud, you want to instantiate, as I mentioned, repeatable fashion, the same VMs. And then you want to add your own software. So you don't want the operating system to be different. You don't want the packages to be different. You want the same version. And that's what you do with the stem cell. The stem cell represents that. You use some kind of a command line tool because it's like all programmers. You shouldn't be worried about GUI and clicking and so on. You want to go at the command line. That's always the best thing. So you talk to the director. You say, I want to deploy this. The director will talk to the CPI, which is essentially a piece of software that understands the cloud. So if you're talking to the Azure cloud, there's a different CPI. If you're talking to the Google cloud, there's a different CPI. You're talking to our cloud, there's a different CPI, the software CPI. And then it talks to the cloud, instantiates VMs, and the director then talks to those VMs. Now, of course, a key part of instantiating the VMs and the stem cell is that there's this thing called the agent that runs on each VM. The agent is where the director can say, hey, I want this release to be on this VM. So it tells the agent, go get this release. Because all of the releases are in some blob store. So the agent goes and fetches the stuff from the blob store and installs it. Now, obviously, it seems very simple. The reality is it also does things like, for instance, the VM dies, then it will reinstall. You have a new version of the release, it will update it, right? Something happened to the network or something happened to the disk, and it will recreate it. So all of this management to keep it alive is fine. The other thing is the scalable portion, right? You could say, hey, I have this installation, it's like 10 VMs. Like Bluemix, for instance, we go to thousands of VMs. So we use Bosch and we say, hey, Bosch deploy and then update the number of VMs to 1,000, and then all of a sudden you get 1,000. So that's the value of the tool, right? So it's pushing all those bits. Again, remember 1960s, you had punch cards? Same shit, right? Different bits. That's it. Right? Conceptually, it's the same problem. All right, so what is a release? So it's packaged software for deployment, right? And you specify, for instance, things like templates and jobs, because in some ways you don't just want to run the bits, like you don't just put the bits in the VM. You start a process, right, out of those bits. That's what a job is. So this is a picture of it. So you write some Go code, for instance. This is the bits that you're going to deploy. Then you configure some blob because you want your bits to, if it has a dependency, in this case it's Go. So you need the Go environment. And the Go environment is pretty big, so you don't want to have to package it in your bit. You say, hey, I want this thing from the blob store. Then you package it because you say, hey, I want to be able to build this code, and then I want to run this app, right? That's where you do this here. You want to run your app. So this is pretty much what a release is. All of this gets put together into one file, like a tarball, and then now you can deploy it anywhere. So that's kind of the value of the release, right? It's very flexible. So when you deploy it, what you're doing is you're saying, hey, I want to take my release and push it to the cloud, and Bosch will essentially start a bunch of compilation VM. Now remember, I'm showing you a very simple example, but in the case of Bluemix, I mean, you can imagine, if you go check it out, you'll see that we have Watson, we have, the Alchemy stuff, we have tons of software. So you can imagine all of these are in different releases. So Bosch is essentially allowing you to take all of these things and getting them ready and push it. Repeatable, scalable, cloud agnostic fashion, right? So once it compiles, of course there could be some dependencies, so it has to wait for this compilation to be done before it compiles this. So it does all of that too for you. That's very important, right? Because typically, as you know, when you compile, you might want certain pieces compiled first. Then you put all the resulting pieces in a blob store because you want to be able to easily download this stuff. And then you instantiate them. So you put, one set inside of one VM, another set, the other VM, and so on. Right? So again, not complicated, but a more difficult problem because you want it to be scalable, repeatable, right, and cloud agnostic. If any of you here, I told you, go and do this for one cloud, and I give you a computer and I give you all the detail, you could sit down and do it. The difference is that this is automated. Why do you want to automate it? Because none of you would want to do this job forever, programming and deploying stuff manually. It's a boring job. You're an intelligent person. You should be doing something better. So we let the tool do it. Okay? That's the key. All right. There is something called the Bosch Dance, and the reason for it is because whenever you start using Bosch, there's a series of commands that you issue that are very common, and we call it the Bosch Dance. So what it is first you say Bosch create release, because you got to create some release, for instance, a piece of software that you're building. Upload the release, so that tells Bosch to take that release and put it in the director, so that now the director has access to it. And then you do a Bosch deploy. And obviously, because you're typically doing some development, you might have some changes to that release, so you have to redo this again. So it's typically something that you have to do over and over again. So this is why we call it the Bosch Dance. So you learn that when you use Bosch. So the director in Bosch is the key piece, right, that I mentioned, that essentially is an API. So it's a server, and it understands how to interact with the client. So you as a client talk to the director. So you tell it, for instance, deploy, right? And it's in its own VM too, right? And what's cool about Bosch is Bosch tends to be very, I guess you could say, self-referential. Everything in Bosch, it also uses Bosch, so which can be difficult for people. But the way to think of it is the director is a release itself that gets Bosch deployed. Okay, it interacts with the CPI and the VM agents because that's essentially the role of the director. The CPI is essentially the interface between Bosch and the IaaS that you're talking to. So if you had your own IaaS here, like some fancy Belarusian, you know, cloud, then you can build a CPI for it. I think right now we have close to 20 different CPIs. So you can deploy the same software in 20 different clouds. All you have to do is change your cloud config. Pretty much, that's it. And the way you implement a CPI is you have to implement something like 13 methods. So there's like a clear interface between the director and the CPI. You have to implement those methods. That's pretty much it. And things like create VM, delete VM, create this, attach this, delete disk, detach this, that's pretty much what you're implementing. And for each one of those methods, there is a properties. So think of it as a bag of information that, as a user of Bosch, you can specify. So you can specify things like, I want to create VM, but I want the VM to be this size. So you specify these things as a bag, right? A set of properties. And as I mentioned, there's like over 15 that are in use right now. I know of 20 because there's about 5 more that are essentially prototype. The stem cell is, in a sense, the image, the OS image, right? The reason we call it a stem cell is because if you know anything about biology, you know that we're all built of cells, but the cells kind of differentiate depending on where they are. Obviously, cells in your brain versus cells in your arm and so on, or your heart. But if you know a little bit about biology, you'll see that all of those, whether they are part of your toes all the way to your brain, they all start as what they call a stem cell. So something that is very common across. So these differentiate into other things. So think of the operating system image exactly as a stem cell. So it starts as a basic Linux kernel with some libraries, and then the agent, the Bosch agent. Then you add software to it. So you differentiate it as you build your cluster. Right? So something like Bluemix is over 1,000 VMs. A lot of the VMs are the same because they're running the applications, but some of the VMs are different because they're running, say, a service. Another VM is different because they're running the cloud controller, different pieces, right? So that's how you differentiate it. So you start with the same and then you differentiate as Bosch deploys it. And the important thing about the VM is that you don't only have the agent, but it also has all of the security updates. You know, as you know, hacking is a real issue on the internet. In the US, typically people say, oh, it's some Russian hacker. They're smart, so they hack things. We hack too there, so it's the same. But the point is that you want to have your stem cells up to date because the security issue is a real issue. So how do you keep it up to date? You're always using the stem cells and upgrading. Bosch, by the way, allows you to take a cluster and say, hey, I've got a new stem cell, redeploy. So what it's going to do is it's going to take each piece of the VMs in your cluster and it's going to stop them, create a new one with the new stem cell, put the new stuff in there, restart the job, right? All of that. It automates all of that process for you. Again, I'm sure any one of you, I would put you in a room and I would tell you do it manually, you would do it. And you would do a very good job. But if I ask you to do this for the rest of your life, I could say, I'm going to give you $1 million every day. You say no. Because why would you want to do this manually? That's what the job. You'd probably invent Bosch, right? And do it. You agree? After 2 days, you'll quit. Then you have 2 million. That's good. So we have two kinds of stem cell, regular and light. And the reason is because the light is essentially a pointer. So instead of creating the stem cell and having all the bits, you put the bits in the cloud and then you give a pointer to it. So when people download the stem cell, they just have a pointer to it, which is good enough, right? The agent is, in some ways, a piece of code that works on the VM that you talk to. The director tells it, hey, agent, this is a new VM, configure the disk, the temporary disk, right? So configure the users there, make sure that everything is set up correctly. Or when I have a release, I want you to install that release. I want you to remove it. I want you to upgrade it, and so on. That's what the agent does, right? So it takes command from the director and then does stuff, right? It sets up the disk, set up network, install releases, start, stop packages, and so on. The only thing the agent doesn't do that we have to do in Bosch is that there is a restart of the jobs, which is done with Monet. So Monet is a piece of software in Linux that allows you to monitor a job, a process, and then restart that process when it dies. So Monet is the only thing that the agent doesn't do. There's talk about changing that, but essentially that's one of the things that you don't have when you that the agent is not doing. So every time you need to talk to the VM and you need to do something to the VM, meaning the director, or you issue a command, like for instance, you can say stop the VM, so we can recreate it. The director will talk to the agent and say, hey, stop all the jobs on that VM. And then when the jobs are stopped, it's going to shut down the VM, recreate it, put the bits again, restart it. Right? Pretty much very simple, but automated, very repeatable fashion. And it's agnostic from the perspective of architecture and platform. We actually have the same agent running on Azure, running, of course, on the Google stuff, Microsoft, Amazon, and also IBM. It runs on vSphere. On IBM, it also runs, we have a prototype version running on OS 3.6, no, I guess Z series, so the mainframe. So we have it running on multiple things, including also on the Power architecture, for instance. So it's just a piece of software that's taking command. Okay. So recently, what we call Bosch 2.0 is we've added a set of features that make life a little bit easier. And if you're new to Bosch, it doesn't appear, maybe some of it may not appear like it's useful, but if you're not, you would see the value. So first thing is we did cloud config. So one of the biggest challenge with Bosch is when you use it, you have to create a YAML file. Now the YAML is easy for human to consume, but it also becomes very complicated because for something like Bluemix, the YAML file can be thousands of lines of text, right? And if you've ever seen YAML, small YAMLs are easy, big YAML, it can be hard. So one of the mission in Bosch has always been to try to facilitate the creation of these things and then also simplifying it. So one of the big things that we did is to simplify it. So before I show you the simplification, let me talk about kind of like the different pieces. So first thing is the deployment info. This is where you say, hey, this is the name of my deployment and what director I'm going to talk to, right? Because obviously a deployment has to be, you know, fixed per director. The releases is where you say, okay, these are the bits that I packaged that I want you to deploy for me. And then you list each one of them, right? And then obviously it has a version and a name. The next part is, because you're going to have a bunch of VMs, you got to network them, connect them together. So you have to specify the network that you want. Sometimes manual, sometimes dynamic. You might have to reserve IPs and so on. That's what you do here. The next thing is you say, okay, well, I'm going to create my deployment for things like, if I know I'm going to target Amazon, I want to specify the kind of instances that I want to create, right? So I create a pool of those instances and I want Bosch to take VMs from that pool. And then I want to also specify my stem cell because, you know, as I mentioned, we keep releasing new stem cells, but you might have a reason to fix on one particular stem cell or say the latest because you want the latest stem cell. The next thing is the disks, right? Because you want, like, obviously depending on the job that you're going to be running, you might want disks that are very fast or very big or a combination of thereof, right? And obviously things cost money, right? I mean, so you can't just put the best disk in the best VMs. What you're trying to do is run a business, so obviously you have to think about the cost as well. So that's why you have to specify these things. Then you specify, okay, when I deploy, how many VMs is it going to start for compilation? And that's an important piece because as you do your deployment, it's going to spin up those VMs just for compilation. So how many of those do you want and so on. And then you want to say, oh, when you do an update, use the canary process and how many canaries. And canary, think of it as, you know, when people used to go and mine, you know, to find diamond or, I mean, I guess they still do this now, right? I don't know if they did this in Belarus, but basically what you typically want to do is you don't want to take your, like let's say we're all miners and we're going to go down the hole, right, to go find gold. Obviously we could all go, but if something goes wrong, we all die. You don't want to do that, right? So you pick one or two. So those are the canaries. So we take, let's say, I don't know, Andre, we say, hey, go down. If he comes back, we know life's good. So he's the canary. And that's exactly what Bosch does, is Bosch will not try to do a release, like an update of everything immediately, because then it would shut down your cluster. So instead it will do a few, and then those are the canaries. And if those succeed, then it knows to do the rest. So it is, you can control, you know, how many of those happen, and then also the level of concurrency that happens for these things. And then obviously the jobs, right? Which is, oh, I want to be able to start these jobs, you know, as you do your deployment. So it's very comprehensive. So this, as I mentioned, can become very big. So what we did is we simplified by sort of separating things that are in the cloud config versus the things that are independent of the cloud. So that way, if you're going to take your deployment and push it to Amazon, then you'd have a different one for that piece for Amazon. And then if you're going to deploy it on SoftLayer, you'd have a different one, and so on and so forth. So that's kind of the value. So you say, hey, Bosch, update the cloud config with my new cloud, and then you do a Bosch deploy. Another feature that we added is orphan disk. This is something that happens a lot because the VMs die, right? I mean, what happens is the cloud, right? As I mentioned, as I showed you, a lot of these problems are the same problems we've had forever. And I don't want to say every problem is the same problem as the past, right? I'm going to sound like your mom and your dad, right? Your mom and dad, I'm sure, every country across the world, they say, I had the same problem 10 years ago or 20 years ago. Yeah, it's the same problem, right? Life was a lot harder for us, right? I don't want to say this, but there are definitely the fact that VMs die, VM will fail. And the reason is because it's software. And because of that, your data, which is on your disk, assuming it didn't die, you might have a disk that has data in it that you need to reconnect, right? That's what we call an orphan disk. So Bosch will know about those disks, right? And it will allow you to essentially say, hey, this disk was orphan, and it will know when. And it will allow you to do something like, I want to reconnect the disk to the, I'm sorry. So I want to reattach a disk to an instance group, so the disk get reattached to the VMs, right? This is a very important feature, as, you know, again, those problems will always exist. So how do you reconnect your disk easily? Obviously, you could also manually do it, but we're in the process of automating things, right? Another one is add-ons. The way to think of add-ons is that you have, let's say, a cluster, and you want to be able to run, let's say, security, and then log rotate jobs onto each one of those. But you don't want to necessarily add it to the manifest. You want to have it as a separate thing, because those things change much more often than the rest of your releases, right? And you want to be able to say, hey, run the security, you know, check, like right now, because I know there's a new issue. And that's what you can do with add-on, is that you can essentially say, hey, I want to add a release that's an add-on, and then specify the name of it, right? And then you push it to your deployment. So in other words, it's a way to simplify pushing specific releases that you want to change often versus the rest of the manifest. Those are, it's through what we call runtime config. So you say Bosch update runtime config, and when Bosch deploy, it will push it. So now if you have another piece of software that you want to run, you don't have to add it to the manifest. You have it as a runtime config. You upload it, run it again. So your deployment stays, and then you can keep adding things to it. That's why we call them add-on. Availability zone is pretty much what you expect, is the division of your cloud config and the instances into different sets. So if you specify those sets, one of the things that Bosch will do is that it will try to do a good job of essentially moving those different VMs that you have across availability zones. And it will try to do it in a way that balances the VM so that you don't have all your VMs in one AZ. You'll have some in one in AZ1, a few more in the AZ2, and so on. It will try to balance it. Lynx is kind of a important problem when you, especially for services where you need to know the IP of something. So you're building a release and it depends on a job that's running on a VM that you don't know. And you need to have the IP address of that job. So what you can do is you can say, oh, that release that's going to have the job that you need exposes an IP. The other one consumes it. And in that way, you can link them together before you actually do the deployment so that you don't know the IP. And then Bosch will resolve the IP when it deploys so that the right IP gets propagated. So you're sharing a cross deployment, right? You need to know the IP. So you could use static IP, or if you have dynamic IPs, better. And when you use a link, you say, oh, this guy is providing, right? And this guy is consuming. And then when you write your release, let me show you this. You can say, hey, for instances, I want to look at the link of this primary IP DB. So you're not specifying essentially the IP addresses directly. You're saying I have a link of it. So that gets resolved at runtime, or at deploy time, I should say. Another one is event. So the director will keep track of a bunch of events. So when you're doing something like a Bluemix deployment, for instance, where we have a worldwide team, you obviously want to understand what the different teams across the world are doing. And you can go back in time with Bosch and see that, right? So those are the new features that we kind of call Bosch 2.0. In the future, and things that we're working on right now, are things pretty much in flight. If you go to Bosch Notes, you can get a little bit more details of all of them. So if you just go Google search on Bosch Notes. One thing is the CLI. We now have a new CLI which is written in Go. It's one binary. The problem is that it's not backward compatible, because one of the things about the current Bosch CLI is that it was not, it sort of evolved, and like any piece of software again, it tends to, over time, be inconsistent. People add new features because there's like an urgency, and then you lose track of sort of like a common design. In the Bosch 2.0, we kind of solve those. But because you solve those, they're not backward compatible. So if you use Bosch right now and you get the new CLI, you'll have to deal with those inconsistencies. So I like to think things of humans and robots, because we're kind of in that age these days. For humans, all of us here, not a problem. I give you a Bosch 2.0, the new CLI. If you use the previous one, it will make sense to you because it's very consistent. You'll get it. You're smart. You'll figure it out. If you're a robot, on the other hand, it doesn't work because you're not smart. You're programmed with the first version. So you expect the comma to be here and the space to be here, right? And the dash to be here, and I expect a particular value. So if you're a robot, it doesn't work for you. You have to be reprogrammed. So if you wrote any kind of scripts, those are the robots, you're going to have to rewrite them. Okay? Multiple persistent disks. So that's an issue that a lot of people have asked, which is you don't want to just have one persistent disk, which is always a problem, because why? You're going to have bigger and bigger and bigger of those. So a better thing is to have many of them. So that way you can partition your data. So now in Bosch, you'll be able to do this. All you have to do is add a persistent disk with S in your manifest, and then you should be able to add those. The only challenge here is that you have to manage them. So in your release, you have to configure the disks versus the agent configuring it for you. Config server is also another one where essentially it allows you to remove passwords and SSH keys from your manifest. So that big file I mentioned has a bunch of disks, passwords in it, and SSH keys. What you would want is to have a pointer to those. So you need to have a secure place to have it. So the config server just defines an API that says, if you have a implementation of this API, in your manifest, you can put pointers to that config server, and then it will fetch the passwords, fetch the SSH keys from there. So your manifest doesn't have any passwords in it, which is very important, right? Because when you start running stuff in production, and you're a big company like IBM, for instance, then it becomes a huge issue. You know, of course, not just us, but also customers of ours have asked for that, and customers of Pivotal as well. So it's a very simple REST API. You can look at it. Another one is local DNS. In the current Bosch, you have to use some kind of a DNS provider for your cloud. Obviously, in your cloud, if you don't have a good DNS provider, then you're in trouble. So what local DNS does is it propagates the DNS information, basically the name and the IP address of all the VMs that Bosch is managing, to all the other VMs. So now the agent knows how to essentially get the list of names and IP addresses. Again, Bosch will manage keeping everybody in sync. And this is a feature I worked on directly. Now, how do you debug in Bosch? I mean, a lot of you probably know this. You do Bosch VMs details, and that will show you, I guess the slides doesn't show very well here, but it will tell you, for instance, the state of all your current VMs. If you do vitals, it actually shows you even more. It tells you, for instance, the disks, percentage usage of the disk, CPU usage, and so on. CCK is a way for you to recreate VMs. So in some ways, when you use Bosch, the cluster might be up and running, and at some point in time, something going wrong, you do CCK, and then Bosch will say, okay, let me try to see what's going on in my entire cluster. And we'll find that some VMs are failing, and it will allow you to recreate those VMs, reinstall packages, and so on. And then, of course, you can always look at a particular tasks. So Bosch commands are tasks, and you can look at the logs for them. So one thing I want to finish with is the where to find information, because that's always the key. So obviously Bosch.io is the start of everything about Bosch. Just go there and you'll find excellent information. Everything, all the releases also, the stem cells, everything is in there. So you go to Bosch.io, you'll find releases, stem cells, manifest, docs, the tracker, which is where all of the current work item on Bosch are. And then their mailing list. And then there's also this tutorial, which I want to highlight. So you may want to definitely, if after this you still have some question about Bosch, this is definitely a place to go. I think in 15 minutes you get a good overview of Bosch as well. There's a bunch of community channels on Slack. So if you're not a member of cloudfoundry.slack.com, I would encourage you to go there and become a member. You can just sign up. And in there's a bunch of different channels, right? So Bosch, the development team hangs out here, so you can find us there. And then for each one of the CPI, there's one, and obviously there's one for the IBM CPI, which I created the first version of. Typically, you get a chance to talk, at a conference or at a meetup like this, but the reality is you're just talking for a bunch of people, right? I mean, obviously I didn't write all of this. I'm just one member of a bigger team. Like Altoros is a part of that team as well, and maybe some of you. So I want to highlight two people in particular. First thing is my Russian friend. He's actually an American citizen now, but he's originally from Russia. Dmitry. He is Bosch man, the brain, the person you go to. So if you have any question, you really want to go to Dmitry. He actually hangs out a lot in the Bosch Slack channel. So if you have any question, definitely, talk to DK. He's also the product manager, so if you want new features, you basically want to talk to him. Pretty much a lot of the slides he reviewed, he loves to give feedback, so he was very kind to give me a lot of criticism for this slide. As I mentioned, very active and pretty much reads all the codes. I'm a PM also on a different project, and I try to do the same too. So he basically reviews everything. Interestingly enough, the #1 Bosch committer is actually not Dimitri and not me. It's Maria. She's also Russian, but American now. So all Russians that are really good, we say, come to us. And Belarusian too. I'm just kidding. But she is the ex-anchor for Bosch. If you go look at the Bosch code right now, you will see her everywhere. And she's just brilliant. I stole a lot of content from her. She gave me permission, but I still say I stole it. And as I said, she's the #1 committer. And she's the one also that wrote this tutorial that I mentioned you go to. Just really a brilliant person. And of course, there's a worldwide team. So Dimitri and Maria are in San Francisco, as well as the rest of the Bosch team. I live in San Jose, which is not far from San Francisco, so that's how I work with them. There is a team in Toronto, and they're doing the config server. There is a team in Portland, it's a very small team. And then there's Dr. Nick. A lot of you know him. And there's actually people all over the world, like obviously Altoros contributes, and there's actually also an IBMer in, used to be in Russia, I think she's now in Germany, that contributes. So it's really a worldwide team, as I mentioned, Altoros. So it is a worldwide team. So if you are involved and you want to be involved, don't be worried where you are, because you know the internet, that's what it does, right? It flattens it, so you can be anywhere. So with that, I want to thank you, and I'll take maybe one question. I know I'm running out of time. Yes. Sure.
Thank you. I have some follow-up question.
Sure.
Can you compare Bosch with other tools, like, for example, package manager like Packer or Docker, plus some configuration managers like Juju, Terraform, Ansible, etc., plus some, for example, console for DNS? Why Bosch is better?
Well, it's a loaded question, right? Obviously, because you mentioned a bunch of tools, and none of them independently do everything that Bosch does, but together you could probably put something together to make it work. I think, I don't have a good answer that says Bosch is better because of this, Bosch is better because of that. The one thing I would tell you is you can look at each one of those tools and you look at the key features that Bosch does, and none of them do all of it. So you could package, as I mentioned, and maybe get there. But if you're looking for scalability, you're looking for cloud agnostic, right? And you're looking at repeatable, and none of them can do it. Just tell me.
No. All of them can do it.
No,
Sorry.
together they do it.
No, not only together. For example, Ansible have all these features. Maybe Terraform, maybe some other tools. So many of them.
But that's what I'm saying. So you have to combine.
As a single. For example, Ansible as a single.
Yeah, but does it do across different clouds?
Yeah, of course. 15 or many more providers, Google, OS, other clouds. It can do it.
Okay.
Yeah, and my question is because, for example, I'm working with multiple clients at the same time, and it's easy to work with multiple clients at the same time with Bosch. Because, for example, with other tools, I can just switch config files, directory, and etc., and it will be work. It will be
same thing here.
It will be necessary to configure each Bosch server into each client, right? So I cannot use one Bosch server with different clients at the same time.
A different client? You mean like a different customer of yours?
Yeah, different customers. Yeah, sorry.
Yeah, I guess, with the new features that we're adding, you'll be able to, for instance, use a config server for different clients, so that way the security stuff, because that's probably what you're talking about, the fact that the keys would be in one manifest, so you can't really reuse it. it's a work in progress. I mean, I'm not gonna say that we optimize for every use case. Obviously, you can find some places where it doesn't work, but generally, I would say things change a lot. So, you know, what you saw with Bosch last year is different than what you have this year, and obviously the next years. And I would encourage you to try it again. I mean, if you haven't, because I think in many ways it's also proven in the sense that we have close to, I don't know, like 50 members of the community using it in production. So.
Okay, thank you.
Sure, you're welcome. We got another question next to you. Still have time? All right, cool.
When we deploy multi-component applications, we have to preserve some certain topology between the components. So in Mesosphere Marathon, we have dependency trees. And do we have such features in Bosch?
You can definitely specify dependencies across the releases. So when you create a release, which is your package software, you can say that I depend on this other release. And what that's going to do is it's going to make sure that those are, let's say, for instance, compiled in the correct order. So you can do that.
That's all?
Sure. I think a big problem, as I mentioned, is Bosch, you know, generally was hard for people to use. And what we're trying to do here is to simplify it. The other thing is I want to finish with letting you know where the name Bosch comes from. Anybody? Nobody? So do you guys know that this project started, of course, Cloud Foundry as well, at VMware? And it started from the people that left Google to go to VMware and started it. And you guys know what they use at Google?
Omega papers.
Yeah,
they had three schedulers. So
yeah.
Currently it's Kubernetes.
No. Well, that's current. It's actually they don't use it at Google. It's the open source. But the project that they use is something called Borg.
Yeah, the first was the working queue. The second was
right.
Borg. And
B-O-R-G, right? So take B-O-R-G, and then last two, flip one more. That says Bosch. Thank you.